You're listening to the N2K Space Network.
And now, a word from our sponsor, SpyCloud, the cybercrime analytics leader. SpyCloud disrupts cybercrime by telling you what criminals know about your business and your customers, so you can take action to prevent ransomware, session hijacking, account takeover, and online fraud. SpyCloud constantly recaptures and analyzes new data from the criminal underground, including credentials, session cookies, and PII siphoned from malware-infected devices. With knowledge of the specific exposed data criminals have in hand from InfoStealer malware on managed and unmanaged devices, security teams can respond with a more efficient and effective process called post-infection remediation that fits seamlessly into existing incident response frameworks. Get SpyCloud's post-infection remediation guide outlining the 7 steps for preventing a malware infection from becoming a full-blown ransomware incident. Visit spycloud.com/cyberwire. That's spycloud.com/cyberwire. And we thank SpyCloud for sponsoring our show.
Yesterday, we opened our show with a call to show me the money, and it seems Europe has answered. The largest seed round for an aerospace startup in France closed this week, the second largest in European space tech history. Are we seeing the seeds of change in aerospace investment?
T-minus 20 seconds to LOS speed rest. Go for deploy. Roger roll.
Today is June 27th, 2023. I'm Alice Carruth, and this is T-minus. Look Up Space raises over $15 million just 1 year after inception. US District Court backs SES in battle with Intelsat. US and UK special relationship extends to new space domain awareness partnership. And I speak to Derrick Walker from Brigham Young University's rocketry team about winning the 2023 Spaceport America Cup. On to today's Intel briefing. We've been discussing the gloomy outlook for investment in aerospace for the last 2 months, so it's refreshing to start our show with positive news. There's money to be made and invested in the aerospace industry after all. Hurrah! Look Up Space has announced the second largest seed round in European space history, and you'll be forgiven for not being too familiar with that name yet. Just 1 year after the company is formed, and it's already making waves, raising 14 million euros. That amounts to over $15.3 million for those of us on this side of the pond. So what does this new company do? They say they're developing new solutions for space situational awareness, and they're focusing on space sustainability. 2 great buzz topics, right? But Look Up Space carries a legacy of aerospace experience, being led by the former head of space surveillance at CNES and a 2-star major general who previously led the French Space Command. Forget look up, we say look out, as the company positions itself as a key player in Europe's new space and aims to become a world leader in space security. T-minus is looking forward to speaking to the founders in the coming weeks. It was the will they, won't they topic of discussion for the spring when merger discussions started between SES and Intelsat, and it seems that those discussions took a bit of an ugly turn at some point. SES says that they're entitled to a portion of Intelsat's C-band payout. SES claims that the 2 communication giants agreed to a 50-50 split of C-band proceeds when they worked together as part of the C-band alliance. This got a little complicated when in 2020 the FCC allocated Intelsat $897 million more in incentive payments to clear the spectrum quickly, and Intelsat refused the 50-50 split. Obviously, SES was not happy about the decision and filed a whopping $1.8 billion, yes, that's a B, claim against Intelsat for compensation and punitive damages. A US bankruptcy court sided with Intelsat, But now a US District Court judge has reversed that decision and has sided with SES in a dispute over the 50% claim, amounting to $421 million of Intelsat C-band proceeds. In case you're not keeping up, the merger talks were thrown out last week. Let's hope that they can continue to be friends. UK Space Command has launched a Joint Task Force Defence Commercial Operations Cell, JCO, paralleling the US JCO to enhance space monitoring in collaboration with the US and commercial space organisations. The UK JCO will implement Spacecom's follow-the-sun model for round-the-clock tracking of space objects. Operating within European business hours, JCO UK expands the timeframe for monitoring satellites and space debris. The cell will issue notices to space operators, or not so, warning of on-orbit threats. This initiative aligns with the UK's defence space strategy to enhance space domain awareness, pledging more than £85 million over the next decade. An advanced compact electric propulsion system, the HT100, developed by Citadel in Italy, has completed an extended qualification firing test. The system, featuring a small, low-power Hall-effect thruster that can generate up to 6 millinewtons of thrust, is set to be deployed on the ESA-supported microsatellite demonstration mission later this year. The HT100 uses Exxon propellant and will be tested in a series of in-orbit demonstrations, including over 1,000 ignition cycles and a single ignition exceeding 600 seconds. The German Aerospace Centre, in collaboration with the French National Centre of Space Studies and JAXA, the Japanese Aerospace Exploration Agency, is developing a rover to explore Phobos, one of Mars's moons. The initiative forms part of the Martian Moons Exploration Mission, targeting a 2024 launch, designed to ascertain the origins of Phobos and Deimos, potentially offering clues about Mars's geological history. The rover, fitted with a suite of instruments including a mini rad radiometer and Raman spectrometer, will characterize the surface of Phobos and help gather samples for Earth-based analysis. The rover is in the final stage of space qualification tests and is expected to be delivered in summer of 2023. China and Egypt marked a significant space cooperation milestone with the handover of 2 models of the Marsat-2. Notably, this project, developed under the Belt and Road Initiative, represents China's first international space cooperation initiative that uses overseas facilities for the entire satellite assembly, integration, testing, and delivery of satellite models. The Belt and Road Initiative is a global infrastructure development strategy launched by China in 2013. It aims to enhance connectivity, trade, and cooperation across Eurasia through the Silk Road land routes, the Belt, and maritime routes, the Road, involving over 60 countries. Space News is reporting that China's main space contractor, the China Aerospace Science and Technology Corporation, has conducted high-altitude parachute tests for the Tianwen asteroid sample return mission scheduled for May 2025. The mission will target the near-Earth asteroid, and please, I apologize in advance for this mispronunciation, 469219 Kamo Oweya, collecting samples to return to Earth around 2.5 years after launch. The Tianwen-2 spacecraft, a major component of China's flagship deep space exploration missions, will also conduct a gravitational slingshot maneuver to rendezvous with a main belt comet in the mid-2030s after delivering the asteroid samples. South Korea has salvaged debris, including what's believed to be the North Korea's first failed spy satellite, according to media reports. The recovery provides a chance to examine the spacecraft and its intended capabilities. The failed launch last month marks a setback for North Korea's space and missile programs, which have also conducted tests of advancing missile technologies that could potentially reach the continental US. Despite these tests, the country's actual level of advancement remains uncertain. Lea Aerospace, an Argentinian company and pioneer in biofuel-powered reusable rockets, recently revealed its BP-100 and BP-200 propulsion systems designed for satellite and spacecraft orbital maneuvers. CEO Dan Ettenberg highlighted their affordability, sustainability, and reliability. The systems propelled the company into the European Space Agency's incubation program, with new facilities set to open in Argentina by end of year. This rapid growth includes collaboration with Argentina's National Technological University. And that concludes our roundup today. But we've included links to all the stories we've mentioned and a few that we did not in the selected readings section on our website, including a breaking defense story on space weapons and preparing for conflict. Hey T-Minus crew, our audience is growing rapidly and that's a big thanks to you. If you're just joining us, be sure to follow T-Minus Space Daily in your favourite podcast app. And also do us a favour. Please share your favourite episodes on social media. It helps professionals like you find the show and join the crew. You can find our social media profiles in the show notes and at space.n2k.com.
This episode is brought to you by Palo Alto Networks, the leader in cybersecurity. As AI-driven attacks increase, organizations can't afford to have network security that's stuck in the past. Discover how Palo Alto Networks can help you predict what's coming and proactively secure against it with a zero-trust, AI-powered network security platform built to secure whatever, whenever, wherever. To learn more, visit paloaltonetworks.com/network security platform.
My interview today is with Derrick Walker, the team lead for Brigham Young University rocketry team, which just took home the overall winners award at the 2023 Spaceport America Cup. I wanted to know how it felt to come top of the 116 teams that competed this year. But first, I wanted to hear about their journey to New Mexico. How did the team come together to win this competition?
As an organization, BYU Rocketry has been competing for many years now in different ways. I was able to participate on the team last year, and so we got back mid-June and started up again from scratch to get ready for the next year. So I started picking new teammates, new people to prepare the rocket in July, and in August we had our first meetings where we started talking about conceptually like what we wanted to achieve for this coming year. And it was really helpful having been on the team, knowing kind of what we wanted to get started with and how we needed to prepare early.
The competition starts in October. Talk me through the process of application and what it is you needed to do to get yourself ready to be able to be accepted into this prestigious competition.
Yeah, we feel pretty lucky. We kind of knew what was expected of us as far as designs and things like that. And so applying to the Spaceport America Cup really just had to do with showing them that you were competent and that you were serious and you were kind of excited to continue. So as soon as we had some initial designs ready, we had some initial plans. And once we kind of get that down in paper, I think that Ezra, the people who run Spaceport America Cup, can kind of see that too and see our commitment to it.
There's lots of milestones you have to reach to be able to get to New Mexico. Tell me about some of the things that you have to put in, reports, for example, before you even make it out to New Mexico for the launch sites.
Yeah, I think there are about 3 major reports throughout the year, some requiring a lot more than others. And one thing that's nice about it is that they expect these things to change, right? And so a lot of it can be team data, some of it can be technical data about what your rocket is going to be doing, even how fast it's going to be going, how fast it's going to be descending. A lot of the hard stuff for us was from a really early point knowing what we wanted the payload to be doing, how we wanted systems to be integrated. A lot of these things that we've gotten used to kind of hoping they work themselves out. We had initially thought of doing air brakes, for example. And so they wanted to see that we were super prepared to be able to do that and that we had all the plans and all the contingencies ready. Even though that wasn't something that we ended up bringing to the Cup, it was a huge part of a lot of our reports. And luckily they were understanding when that was something that we decided against doing a few months before the competition.
So talk me through your rocket. Explain to me what it is you were telling the judges and the range safety officers.
Yeah, so our rocket was named Solitude. So that is a shout toward one of the mountains here in Utah. So it's 12 feet tall, one of the biggest that BYU rocketry's made so far. It's 10,000 foot COTS, so commercial off the shelf. So we were able to buy our own motor. But as the judges and other individuals would come up and talk to us, we had a few kind of talking points that we thought were special about this rocket. The first being our payload. Our payload, we wanted to be able to eject from the rocket on descent. And so a lot of times we've seen that done kind of straight through the body of the rocket. So as the parachutes come out, either the payload comes out and pulls the parachute out, or more likely the parachute comes out and pulls the payload out. Well, personally, I know BYU Rocketry has in the past, and I know a lot of people have ejected payloads. I didn't want the payload anywhere near the parachutes. I liked the idea of keeping those systems separate so that nothing would get tangled up. There wouldn't be any problems there. And so we ejected our payload radially. And so when you see a picture of our rocket, that's the first thing that comes to mind is, why is there a big hole in the side, right? That's usually not a good thing to have holes in your airframe. So that was a big challenge for us. And then the other thing about our rocket that we were proud of is how much of the airframe was student researched and developed. And so that means that we made all of our own tubes, we made all of our own couplers, and this is the first year that we actually made our own layup and carbon fiber fins. And there was a lot of different math and simulation and modeling that went along with that. But that was something that we were proud of and that we recognized that not every team has the opportunity to do. And so we chose to kind of focus on that.
Once you've gone through your checklist, you've gone and spoken to the judges, you then get to go out to Spaceport America. Tell me about that launch experience. When did you launch and how was your flight?
So we learned from last year and from many previous years that the wind is brutal at Spaceport. So much of people's kind of flight performance as far as their altitude depends on that wind. So we knew that we wanted to launch the first day, and we knew that we wanted to launch very early in the morning. So we tried to do as much preparation as we could before the day, as safe as we could, so that we knew we did many practices so that we knew exactly how to go through all the checklists and be ready for Wednesday. So we didn't quite get out in the first salvo, in the first group of people out to the pad, which was disappointing for us. And we knew that the wind was picking up that day. We had this counterweight system in our rocket. So we had kind of a ballast system where we could adjust the weights depending on what the wind would be doing. But we knew that at Spaceport, you prepare your rocket and it can be 2, 3, 4, sometimes 5 hours until it actually launches and you're not able to make any changes on it. And so we had to just kind of guess what the wind was going to be. And I think we got pretty lucky. We were one of the last ones to launch on Wednesday before the range closed for high winds. And overall, it was an extremely successful flight. We were about 70, a little less than 70 feet off of our 10,000 foot goal. And we recovered the rocket with absolutely no damage. And the payload ejected successfully, which is something that I was a little bit nervous about, but super excited about too.
So as you mentioned it, what was the payload that you guys took up in your rocket?
Yeah, so our payload was a demonstration about the radiative night sky cooling effect. And so basically that means that different coatings and different materials and different colors are going to reflect and absorb different amounts of IR light. And the most common example of this is like a white coating versus a black coating. And so on buildings and things like that, it's really important to know how much IR you're going to be absorbing to save energy costs. And we had a hypothesis that different coatings would perform differently at different altitudes as well. And so as we ejected at 5,000 feet, we were able to see the differences between a just kind of white paint, acrylic-based coating and a silicon-based coating. And that was kind of the goal, to see that gradient and the difference between 5,000 feet and ground level.
Excellent. What a great way of approaching payload work. So you come to final day and it's results day. Talk me through that process of being at the Pan American Center and waiting for those results to come in.
Well, it was exciting. It's great to launch on the first day, but it means you're sitting and waiting and wondering for 3 days, right? So I was super hesitant. I didn't really think that winning the entire cup was something that was possible. In the past, I'd look at other teams that had done it, and for some reason, they just seemed like they were in a different tier. And I don't think that was really a rational thought, but when some of the newer members on our team, they were talking about it, and they were thinking, well, there's not many places where we would have lost points. I wasn't that confident going into it, but I think I was really just trying to temper expectations. So it was certainly a surprise, but I'm really proud of my team and everyone who worked on the rocket in helping us get both the General Cup and also the trophy for the excellence in simulation and modeling. We're also very excited about that. I'm most proud of the simulation and modeling because that's one that I mentioned. We met in August and we talked about what our plans for the Cup were, what we wanted to kind of accomplish. And that was one of our first goals. We said, hey, like high power rocketry is such an interesting activity because it can be a hobby and it can be a science. And we all kind of lie somewhere on that spectrum of how much analysis we're going to end up doing. And we said that, hey, we want to really kind of upgrade our understanding and our knowledge of what is going on in the rocket. Like I said, we've had a club that's been very established for many years, which means that we get a lot of different kind of habits. We know how to roll a carbon fiber tube. Do we all know necessarily exactly why we do it like that? Maybe not, because that's how we were kind of taught how to do it. And so this year we said, hey, we want to actually do the math, run the numbers, do the analysis on why these things work. And so the simulation award was something that we were actually really hoping to make a effort at all year long. And so I'm almost just as proud of that one. I'm super proud that we were able to do that. And then, of course, we ended up winning in our category, 10,000-foot commercial off the shelf, and then the General Cup as well.
So all added up. Tell me, what's the reaction been from your team and from people that have supported you and from BYU, from Brigham Young University?
Yeah, well, we're just super excited. We think this is a huge thing for BYU rocketry. It's a very big club on campus. I said that there were about 12 or 13 people who went to Spaceport America, but the overall club has gone from 50 to 90 people every year. And so there's huge interest in rocketry. There's huge interest in the aerospace industry amongst engineers right now. And so I'm really excited for what this might do to help grow the club, what this might do to help grow kind of aerospace interest at BYU. And the support from friends and family and the university has been just amazing. So I've been surprised to see all of it, really. I'm excited to spend this next year kind of helping younger rocketeers get ready for spaceport and get ready to get their certifications. But I'm also excited to go out and continue in the industry, continue in the space, and kind of move along in my career and see what's next for me.
We'll be back after this.
Now, a word from our sponsor, the Johns Hopkins University Information Security Institute, currently seeking qualified applicants for its innovative Master of Science in Security Informatics degree program. Study alongside world-class interdisciplinary experts and gain unparalleled educational, research, and professional experience in information security and assurance. Interested U.S. citizens should consider the National Science Foundation's CyberCore Scholarship for Service program, which covers tuition and a $6,000 annual professional development allowance, as well as providing a $37,000 additional annual stipend. Apply for the scholarship and the fall semester by March 1st. Learn more at cs.jhu.edu/MSSI.
So congrats again to Brigham Young University rocketry team for taking home the trophy at the world's largest student rocket competition. Now, I've been talking about this competition for the last few weeks and reported on it when many other outlets have not, and I wanted to discuss why. Why is a student competition so important to the aerospace industry? Well, these bright minds represent the future of our industry, and I can tell you what I observed is that the future looks promising. Nearly 50% of the teams came from outside the US, and a lot of the overseas groups had a lot more hurdles to overcome to make the competition. But not only did I observe teams from Canada, Brazil, Australia, and Italy take home awards at the end, I also saw international collaboration in fixing problems. Take the team from South Korea that experienced a premature firing at the pad. Mentors and teams from around the world came together to help troubleshoot, offer advice, and equipment to ensure that they got their chance to launch. They unfortunately did not put it together on time, but they made strides in finding the right people to work with, and that's what fills me with hope for future pursuits in space for all of humanity. That's it for T-Minus for June 27th, 2023. For additional resources from today's report, check out our show notes at space.n2k.com. We're privileged that N2K and podcasts like T-Minus are part of the daily routine of many of the most influential leaders and operators in the public and private sector, from the Fortune 500 to many of the world's preeminent intelligence and law enforcement agencies. This episode was mixed by Elliot Peltzman and Trey Hester, with original music and sound designed by Elliot Peltzman. Our executive producer is Brandon Karff, our chief intelligence officer is Eric Tillman, and I'm Alice Carruth. Thanks for listening.